This video I'm going to discuss about great circle sailing. Well, we need to know what is the shortest distance between any two given point. So there are 2 points here, point A and point B, and if they are on the plane surface, then the shortest distance will be the distance along the straight line. However, if these 2 points are not on the straight line, then what is the shortest distance? Let us consider that these 2 points are on the sphere. Say this is point A and this is point B, and these 2 points are on the sphere. So we need to find what is the distance A to B. Well, this will be the arc of a circle, and well, this is the arc of circle which is passing through these 2 points, and this circle is having the greatest possible radius. So we can say that this circle is having the greatest possible radius. That means this circle is passing through the center of this big circle. So we can say if the radius of the circle is less or reduces, the distance along the arc will increase. Hence, we need to have a circle which is having large radius. Now let us consider the case of Earth. Earth can be considered as a spherical shape. Actually, it's the oblate spheroid. And if it is a spherical, then a straight line track for large distance is not possible. What we have is the shortest distance between any 2 points on the surface of Earth. So we need to have a shorter arc of circle which passes through the 2 points, and of course this circle is having the largest radius. Well, let's revise it with this concept. This is point A and this is point B. So the shortest distance between these 2 points is the shorter arc of great circle. So this is a great circle, and the definition of great circle is that the center of great circle passes through the center of the sphere. And since Earth is a sphere, we have considered Earth as a sphere, so the center of the Earth and the center of this great circle is same. Hence the radius of great circle is also the radius of a sphere or Earth, which is maximum. It should be noted that if this is a small circle, then this small circle is having a different radius, which is smaller than the radius of great circle, which is passing through the center of Earth. Hence, we can say that the shortest possible distance is the great circle distance on the Earth. So the rhumb line distance, which is also called as a straight line, and the great circle distance have some difference, and we can have a considerable saving since the great circle distance is the shortest distance. So we can have a considerable saving, especially in east-west direction. In the east-west direction, we can have maximum saving. However, in north-south direction, when the distance is north-south, then saving is a minimum because you are traveling along the path of meridians. This is north and this is south. Also, if we are sailing along the equator, so this is equator, then the difference in great circle sailing and rhumb line sailing is almost nil. Well, if you are sailing in high latitude and east-west direction, so this is east and this is west, and sailing in high latitude, this is say North Pole, and this is south pole, then the saving is maximum. The difference between great circle distance and the rhumb line distance is maximum. So the sailing along the great circle track requires continuous change of course at every point. If you need to sail along this great circle, you need to change the course at every point. However, this is difficult and also impossible. So we have a solution, and the solution is that there is a series of short rhumb lines which are approximating the great circle track. Let's go back here. So this is a series of short rhumb lines, and this makes the great circle. So vessel steer some course for some time and then change the course by small amount and keep changing the course like this. That is how we can do the great circle sailing. Now if these 2 points, say point A, let me just mark here, this point A and this point B, both are in same hemisphere. So this is a north pole here, this is equator, 0 degree. So the great circle will curve towards the pole. So these are in the northern hemisphere. This curve will, the GC will curve towards north pole. Similarly, if they are in different hemisphere, say point A is in southern hemisphere and point B is in northern hemisphere, then GC will curve towards the pole of higher latitude. So here the latitude of B is high, so it will curve like this in this direction. However, from A to the equator, the curving will be in this direction towards this pole. Let's have a typical example. Both these points are in a different hemisphere. So both these points are in different hemispheres. This is point A and this is point B. Say this point B is in northern hemisphere and this point A is southern hemisphere. So here the curve will be, the GC will, since it is in southern hemisphere, it will curve towards this pole, P dash we can say, and from equator to this point, since this is in northern hemisphere, the GC will curve towards this pole. Well, in this case, if the value is same, only the names are different, say 20 degree north, A is 20 degrees south and B is 20 degree north, names are different but the value is same, then initial course and final course of the great circle track will remain same. Now let's solve this example. Suppose this is point A, which is 20 degree north and 70 degree west. Point B is 40 degree north and 50 degree west. This is the equator. Just for sake of understanding, this is north pole and south pole. We need to find great circle distance, initial course and final course. So we need to have a formula, and which is the cosine formula. The cosine formula says that, let's use the cosine formula, and the cosine formula says that cos of this side, say cos AB, will be cos of adjacent side, that means cos PA and cos PB. Let me just here, cos AB will be cos PA and cos PB plus sin PA and sin PB into cos P. Cos P is this angle. So here equator to this point A was a 20 degree. So PA will be 70 degree. Similarly, from equator to B was a 40 degree. So B to P or PB will be 50 degree. Well, I can put this value, this is PA, which is 70 degree, PB is 50 degree, same way sine 70, sine 50, and cos P. The value of cos P is 20 degree. Say this is the longitude, which is 70 degree west, and then you are going to go to 50 degree west. That means from where more west, we are going to go to less west. So this, the value is 20 degree east, and this is called D long. So here the value was a 70 degree west, and now here on this meridian the value is 50 degree west. So we are going towards easterly direction. Now after punching the values, and here I am using this Casio FX 991 MS Calci. After punching the values, I get AB is equal to 26.32660,753, and it is quite useful if we use all the digit. So I just multiply by 60, and after multiplying the 60, let me just mark here, I get this value, and I can round off, which is 1579.6. that is the great circle distance. Now if I need to find the initial course, again I can use this cosine formula. So the use of cosine formula is simple. Here cos PB is equal to cos PA cos AB plus sin PA sin AB into cos A. So this time we have used this formula considering cos PB, considering this side. This side is equal to cos of this side PA and PB plus sin PA and sin PB and cos of this angle cos A. Similarly, we got this value after punching the values here, and the value of PA, value of AB we had just calculated here. Let me just scroll it up, and I have taken this value only, 26.3266. This is good enough to use. So I get this angle A is equal to 36.2122, or in degree 36 degree 12 minute 43.99 second, and I can round off to 36 degree 12.7. So if this is the ship, so this angle is 36 degree 12.7. I can name it as north 36 degree 12.7 east, or simply 036 degree 12.7 true. Similarly, I need to calculate this angle B. And how to calculate this angle B? Well, the angle B, I think just let me just clear this so it's much better. This angle will be, how this angle will come in this picture, cos PA, that means this side, is equal to cos of this side and cos of this side plus sine of this side and sine of this side, and angle cos angle B. Well, it's the same way, and now we have this equation. The cos B is equal to cos 70 minus cos 50 is into cos 26.3266 divided by sin 50 and sin 26.3266. So we get this angle B directly, 133.5564183. We can convert into degree and minute and second, and simply I will have this value, 133 degree 33.4. Well, this is this angle. This is this angle. We should be very careful with this. Let me just go up here. We have found this angle B in this direction. So if this is this angle, and you know this is the ship is heading in this direction, the total is 180 degree minus this angle, will give me 46 degree 26.6. So I have this angle. I can write course as 46 degree 26.6,